This presentation is intended to introduce you to a few free energy devices, but please understand very clearly that this presentation must not be thought of as an encouragement that you should attempt to construct anything shown or discussed here, as this presentation is for information purposes only. As designed by John Bedini. This is a circuit which is very well known, but this particular version has been modified to be self-charging. Most battery chargers have the problem that they run their drive battery down when they operate. Usually the battery being charged has to be at a different voltage level in order to avoid draining the drive battery directly into the battery being charged, instead of powering the charge circuit only. John Bedini's simple schoolgirl charger is an example of that style. The following battery charger manages to charge its own battery as it goes along. You can see from this diagram here how the system operates. The left-hand side of this diagram is the battery charging part, and the right-hand side recharges the drive battery, and a switch is used here to change between the charging of the drive battery and the charging of the battery which is being charged. The circuit is fairly subtle. The circuit on the left feeds pulses to the battery, and the switch that changes the operation over is like this. This is a typical micro switch which is readily available on the market. It's easier to understand if you see the two parts of the circuit separately. When the battery being charged is being charged itself, the micro switch is in this position, which connects the drive battery through the drive coil to the transistor, which is a very well known 2N3055, or in its more convenient packaging, TIP3055. The coil here is energized when a magnet on the rotor moves past the coil, creates a voltage in the trigger coil winding, and that goes through to the TIP3055, switching it on and driving a strong current through the drive coil here, and as a result the rotor magnet is pushed along by the back EMF spike created in the drive coil. When the other side of the circuit is operational, the micro switch is in this position, and the pickup coil here is operated when a magnet moves past it. The diode bridge here of 4 diodes converts the voltage in the coil to a voltage which charges the driving battery, and those are the two sections of the circuit and how they work. A key feature of the circuitry is that the alignment of the two coils against the rotor are such that if a magnet is in front of one coil, then the other coil is halfway between two of the magnets. So they're actually operating out of step, and that allows the micro switch to switch the output between the two circuit sections. This particular circuit was built in a fashion which makes it very wide and very heavy. It's 6 inch in diameter, which is 150 millimeters, and it is roughly 2 inches wide, probably because of the size of the magnets that were to hand when it was being built. The magnets are paired up, and their north poles are facing outwards. It's not part of this design, but it's interesting to note that a much greater effect can be had from any system of this style if the stator coils are wound with two strands of wire and connected like this, so that the coils are interconnected, this method, that sort of style increases the input current typically by about 15% and the output current by 65%. If you do it on one pair of magnets, and if you do it on the 4 pairs of magnets, the overall gain is something like 200%. It is of course not essential to have a moving rotor to do battery charging. A Russian reader who goes by the avatar of Alex Core has produced quite a number of very effective battery charging circuits which are motionless. This one shown here is the first of his circuits, and it is extremely simple in appearance certainly. It's again slightly subtle in the way it works. He uses a coil which is wound on a cardboard former of 1.5 inch diameter. That's 40 millimeters, and that particular coil is powered by a transistor. In this case he's doing it using a BD243C NPN bipolar transistor. He's using a diode from the collector to feed the back EMF pulse into the charging battery, which is at a different voltage level to the input battery. He's using also then an NE555 timer chip to generate the pulses, and the way that he's organized the circuitry here with these values means that the pulses produced by the 555 are only positive for about 5% of the time, and it runs at 35,000 pulses a second. The circuit generates more than 200 volts as the peak of the signal. You can see that by connecting a diode and a capacitor across the output and letting a voltmeter show you what the actual output voltage peak is. That peak is actually sufficient to charge 4 output batteries rather than just one if you wanted to do. The 5.5 timer produces very short, very fast pulses. They only power the output coil very briefly, and so the resulting current draw from the circuit is actually very small. It's an efficient and effective circuit. I had one man email me saying that he used to charge a battery with his mains charger, and he then built this circuit and powered the circuit with his mains charger and charged the battery via this circuit, and he said that this battery charged in just half the time that it took using the mains charger directly. People get the impression that you have to have complicated circuitry and the like to access free energy. This is not actually true. This design here from Milkovich has a coefficient of performance of 12. In other words, the input power that you have to put in to make it operate is only 1/12 of the output power of the system. It's a combination of a heavy lever and a pendulum, and for operations like pumping water from underground using a lever pump operated by hand, the pumping of the water, especially in a warm country, is a hard task to undertake. It is tiring and difficult. With a system like this, however, all you have to do is keep the pendulum swinging, and that is something that you can do with one finger. So it makes the operation of pumping water very much easier, and it's very much easier because you are getting an energy gain drawn in from the gravity field. It's not the only thing that operates like that. For instance, this pendulum here, which swings from side to side, has been running for 2 years non-stop when this photograph was taken. It's got a rocker arm on each side, a pendulum shaft going all the way down, and a weight at the bottom, which is a powerful magnet on each side. And there is a little housing here which allows a plate to slide up and down, and the plate itself has got magnets inserted into it. This is the plate connected by a cord to the lever arm above, and what happens is the magnet pendulum, as it swings towards, say, this side, has this plate dropped in front of it, and that takes some of the energy from the pendulum as the pendulum swings into the magnetic field driven by impulse energy, or momentum if you prefer, and that then gives the pendulum a slightly extra push on its way back, and that works extremely well. And while a pendulum would normally stop within certainly a few minutes, in this case, using this sort of system, which is purely mechanical, there's no outside energy force at all other than gravity itself, this pendulum has been running non-stop now for well more than 2 years. Moving on, we come to a system devised by Pavel Imres. It was set up in the 1970s, and it is effectively an optical amplifier. It has a gain of more than 9 times. And what it is a quartz envelope here, which has 2 pointed electrodes inside a quartz envelope which has xenon gas in it. The xenon gas is under pressure, and it has a dielectric material inside as well. The higher the pressure of the xenon gas, the higher the overall gain. Now normally you would supply mains power to a step-up transformer which would provide the current to drive one neon tube or one lighting tube. But with a system like this, the fluorescent tubes, which are the load, are many in number. You can see from here there's a whole row of them. The patent that he has includes bench test results where fluorescent lamps were needing an amount of 40 watts of electrical input power to give 8.8 watts of light output. The rest of the input is converted to heat. That's an efficiency of about 22%. During the bench tests, each lamp required 0.9 watts of input power instead of 8.8, and it produced the same amount of light output, and that's a lamp efficiency of more than 900%, and the power input was only 2.25%, 2.25% of the original 40 watts. That's quite an impressive performance for such a simple and passive device. Next we come to one of the devices built by Don Smith. He promoted the magnetic transmission of power, which is particularly attractive in that many copies of the output power can be taken without increasing the input power in any way. This picture here shows his construction. You have a central coil which acts as a transmitter, and you have, in this instance, 3 receiver coils, each of which produce a copy of the input power and allow effectively as many as you want to be used around the transmitter. You will notice that the coils are all at the same distance from the transmitter coil. That's not an accident, because the transmission of the power varies somewhat from place to place, and so it's most effective to have the receiver coils positioned at a peak position for the signal. He starts by jacking up the mains power or battery power, whichever you use, using a device which is sold to light neon tubes. This central transmitter device is a Tesla coil, and though a lot of people don't seem to be aware of it, how far along the transmitter coil you have the primary positioned, it controls the ratio between output amps and output volts. This is an interesting system because it's an exponential system. The output is related directly to the square of the voltage and to the square of the frequency. So if you double the frequency, that is taking it up from say 60 cycles per second to 120 cycles a second, and double the voltage, taking it from 110 volts to 220 volts, you raise the output power by a factor of 16 times. In his designs, Don raises the frequency from around the 50 or 60 cycles per second to about 35,000 cycles per second. That's a factor of 700 times. That gives an output power gain of 490,000 times. He then also raises the voltage to 9,000 volts, which is 40 times greater than the mains voltage, giving an output power gain of 1,600 times. Doing both of those things together gives an output power gain over the input power of 784 million times on each of the several outputs. The gap between the receiving coil and the transmitting coil is always chosen carefully, as that distance has a major effect on the signal received by the receiving coil. This is an interesting system, and one that's probably worth paying attention to. Don Smith also has another design which is quite convincing. He uses a large 6-inch diameter, 4-foot tall plasma tube, and on that he mounts two plates, one of aluminium, one of copper, insulated by a layer of plastic, and that gives him an output power directly from the plasma tube itself. This is a technique which he patented, and he received a patent for this. It was accepted, and he uses not necessarily a plasma tube, but a metallic tube, or a tube which can be generated into the form of a magnet with a north pole and a south pole, generated by a coil of wire wrapped round the end of the rod and powered by an electrical source. The capacitor can have more than just two plates. In his production model, I think he had 21, and it is powered, or the power from it is taken off and provided to a load. This is an interesting system that has the potential of considerable power. We come now to an interesting device which is well known. It's called the Tesla switch. Nobody knows why, because it comes from a patent by Carlos Benitez, who was a talented Mexican engineer. The Tesla switch was made famous by the staff of the Electrodyne Corporation, who built and tested it for 3 years solid, although admittedly the Electrodyne Corporation denies that fact. It did actually happen, as can be seen from ancillary things. The circuit that they promoted is shown here. It has 4 batteries, and the batteries are connected initially two in parallel and 2 in series, and that puts 24 volts in theory across 12 volts, and that is a 12 volt difference. The actuality is the batteries shown in this circuit are not 12 volt batteries. They started life as them, but after the years of testing that the Electrodyne people used, those batteries became conditioned and they rose to a voltage of 36 volts for each battery. And the system is very powerful in that those conditioned batteries could be disconnected from the circuit, fully discharged by driving a load, and when connected back in the circuit will be recharged inside 1 minute. So this is a powerful circuit capable of driving 70 horsepower motors. The load, which is indicated down here in the diode bridge as a DC load, is supposed to be an inductive load rather than just resistive. The circuit can be implemented with mechanical switching, as the Electrodyne people did, and it has effectively 3 switches which are on at a moment when the 3 blue switches are off, and the switching changes over from time to time. It actually changes over quite rapidly. In this circuit they say the switching rate has to be over 100 times a second and not more than 800 times a second for the circuit to work well. They operated the switching by using a little motor with a speed control to drive a rotor disc. The rotor disc has got 3 conductive sections on it. The sections are all 60 degrees, both the conducting and non-conducting sections, and they've got 3 switches on one side and 3 switches on the other side. And when the switches on one side are short-circuited together to form a down and up connection on S1, S2 and S3, being switch 1, switch 2, switch 3, the other 3 switches, switch 4, switch 5, switch 6, are pressing against an insulated section of the rotor. Now that does work, and work quite well. It requires probably a higher degree of skill in constructing than the average person would find convenient. So it's quite possible to do that in a more simple way, and I'm suggesting that the rotor here, which spins round, has got conducting strips on it to connect the wires together. The green wire, the blue wire, the red wire are connected together by current flowing through these conductor strips on the rotor. The system is probably easier to understand looking at it sideways. The rotor arm, the stator arm here, is held down by a spring. It's a rigid stator arm, and the spring gives it the press against the rotor. And the same on the other side. The spring presses upwards, giving this arm a press against the in this case the non-conducting section, this case the conducting section of the rotor itself, and that gives you a switching system that works okay. This is the way that it operates. You've got 2 batteries in series and 2 batteries in parallel, and that means the current flows from the higher voltage through the lower voltage. The second state is when you disconnect those and reconnect them the other way round, so that these 2 batteries are in series and these other 2 batteries are in parallel. And because of the voltage difference between the 2 in series and the 2 in parallel, makes the current flow round in the opposite direction. Now that is interesting. The Electrodyne system let me rephrase that. The Electrodyne system relied solely on the ability of the diodes to break down when reverse biased. The original design of the circuit, which was done in 1916, doesn't use any diodes. They weren't conveniently around at that stage, but it does have an induction coil generator in addition to the battery switching. Now that induction coil generates high voltage pulses very rapidly, and it will in actual fact generate a voltage across the load, and it will also provide voltage to the batteries. Now Carlos Benitez is nobody's fool, and he also patented a 2 kilowatt generator. It runs off a battery and it charges an identical battery when it's running, and it produces 2 kilowatts of continuous free electrical energy. It's worth taking a look at that particular patent. We come on now to another well-known device. It's called the Eklund-Brown magnetic generator. It's an interesting concept. It produces an alternating magnetic field by using a rotating magnetic shield. It's actually quite difficult to shield magnetic flux flowing through air or metal. What he did was he used successive layers of iron insulated from each other in 2 strips, and they mounted the strips, one vertical, one horizontal, to form a plus sign magnetic shield. And what he uses is 2 horseshoe shaped magnets which are generating a magnetic field between them from north to south here and from north to south there. The pickup coil is wound on an eye-shaped piece of iron, and the alternating magnetic field caused by the rotation of the shield, which is achieved by a little motor which runs through both of the horseshoe-shaped magnets, creates a fluctuating magnetic field in the pickup coil, which, as in conventional generators, produces an electrical output current. The system can be, in my opinion, improved by using more than one coil, but the method of operation is quite simple. When the motor turns the masking shaft round to this position, this strip insulates between the north of the coil, north of the magnet, through, while there is no blocking between the coil core and the south of these magnets. In position 2, which is 90 degrees further on and happens 4 times per revolution, this blocking is removed and the blocking on the right is introduced, and that's how the coil gets an alternating magnetic field. But there could of course be 2 coils. There's no reason why you shouldn't have a coil on both sides, because if you have a coil that works properly on side 1, there's nothing to stop you having a coil working sensibly on side 2. That is, when you look at it from the end, you can see that the 2 coils will operate together. There could of course be 4 coils, and these will be operated once per revolution each. But take a look at it and you can understand from the position of it what it looks like. There's a lot more information on this, and you find it in my free energy ebook, which can be downloaded from www.free-energy-info.com/capital PJK lowercase book.pdf. Some people have difficulty in understanding how things are made. One of the things that bothers them is the wire that's used to wind coils. The wire is enameled solid copper wire, It's available from a lot of suppliers such as the Scientific War company or other suppliers, and it's worth getting the solderable version. The solderable version is where the enamel is a type that burns off at the temperature that soldered joints are made. So you can actually twist two enameled copper wires together without cleaning them and solder the joint, and when you solder it the paint burns off and the joint is good quality. There are various circuits that call for a neon bulb as a spark gap. They're quite simple devices. They're very small, they're not expensive, and they're available from a lot of different suppliers. There's one particularly high performance, very fast rectifier diode. It can handle 8 amps, 500 volts, and it switches in 50 nanoseconds. It is available from places, but it's probably a lot more expensive than some of the diodes that can be used. Then there are transistors such as the 2N2222, which is very popular. There are miniature toggle switches, on-off or changeover. There are resistors of various wattages. Unless it's specified in a circuit, any resistor you see is likely to be a 250 milliwatt or quarter watt resistor, the typical resistor that you find available anywhere. Then you have switches. Some of them are rotary, and they go from one pole switching around to 12 different positions, 2 poles switching around to 6 different positions, 3 poles switching around to 4 different positions, and 4 poles switching around to 3 different positions. Those are useful and quite cheap switches. You have things like battery boxes, which will accept batteries either AA size or AAA size. You've got LED arrays which produce a lot of light for quite low power. You've got multimeters, voltmeters and the like. The one I use cost me less than £2, shipped in from China. They've doubled the price since, but it is a very good meter in my opinion. Then you have magnets, either neodymium or ferrite. They're available from various suppliers, typically on eBay. And then you have capacitors. These are electrolytic types, and can be bought in lots of different styles and sizes. And ordinary LED diodes, which will project light in different colors if you want. And then copper plated or copper stripped Paxilon panel boards, which you can use to build prototypes of pretty much any type. Those are the devices which are easy to get, and I suggest if you want them that you take a look on eBay.